Hello and welcome to a Maths with Harry lesson. In this video we're going to be having a look at cubic graphs. Now for the majority of your time doing maths you've seen straight lines, you've seen quadratics, and a straight line just has a variable of x. So we've got y equals something 2x plus 3 or 7x plus 9. It's just got one linear x in it, and that's because it's a power of 1. Then if we think about quadratics, what we have is, well, the general form is ax squared plus bx plus c. A has to be greater than or less than 0. It can never be 0 because it has to be a quadratic. And we have x squared, so the highest power in a quadratic is 2. Now we don't stop there, we've got highest powers in a graph being 3, in a graph being 4, in a graph being 5. We can continue. And when we have a power of 3 in a graph or in a function, the equation of a function, we call that a cubic. And today we're going to have a look at how we can graph cubics. So we're going to first of all introduce the general form of a cubic. We know, like I said, quadratic has a power of 2, so a cubic has a power of 3. And if we had y equals, the general form to graph a cubic is y is equal to ax cubed plus bx squared plus cx plus d. And a, b, c and d are constants. So what a constant is just a number, okay? We know the values of a, b, c and d, and the variables is x. So we put values of x into there, and we know our coefficients, a, b and c and d, are constants. Okay, so what I'm going to first have a look at is 4 different types of cubics. They're a little bit trickier than quadratics, and that's why you don't really see many cubics at GCSE. The first cubic I'm going to have a look at is the general cubic, okay? So this is kind of like the general just y is equal to x cubed, or some multiple of that. The cubic graph looks like this, okay? So it could be y is equal to x cubed, or it could be y is equal to 2x cubed. I don't really know. I've not got any scaling on my graph here. You can see I've just got the x-axis. I don't have any numbers on the axes. It's just to give me the general idea of the shape of the graph. So that's what the general cubic looks like. It comes up from here, and just like our quadratics, they continue all the way up like that, okay? But I'm just showing you the red part of the cubic there. It goes all the way down here, and then it comes up. It passes through the origin here. We could maybe add that on in orange, the origin, 0, 0. It comes up like that, passes through the origin, and then kind of turns and continues all the way up there, okay? Now that is the cubic when a is greater than 0, okay? A is greater than 0, we get this general shape, okay? But what happens, like I just said, that would just be kind of some multiple of x cubed. Y is equal to some multiple of x cubed there. What happens if we have these 3 extra terms? So we have a squared term, an x term, and a constant on the end as well, just plus d. Well, the same case when a is positive. This is what the graph would look like. Not that one, wrong one. Come down here. It is that one. Okay, so again, here, a is positive, but we can see here, we start here, but we don't come through the origin in the same way we did up here. We come through, we go all the way up, we then have this point here, we come back down, and we still do pass through the origin, we just get there a little bit differently, so there's the origin. We then come back down and get to this point here and then shoot all the way back up again. And again, our graph continues down there as well. I'm just showing you part of the graph. So we can see that those are two types of cubics when a is positive, a is greater than 0. And just like quadratics, a cannot be 0, because if a was 0, then that term would disappear, and we would just be left with those 3 terms, which we can see is just a quadratic. Okay, so a has to be greater than or less than 0. It cannot be 0. So we can see those are two examples of cubics. Now I might introduce here, we might not use this in this video, but you're definitely going to use this terminology at A level, and you might have seen it at GCSE before. We know that, well, we have used this terminology. Those three parts there are the roots, so I'll just write that in blue there. Those are the roots. The terminology you probably haven't seen before, you might have done, I'm not sure, is, and we'll do this in green, what those 2 points there are called. What we can see is we've got the graph coming up here. We then pass through this first root. We pass through the x-axis, so that must be a root. We then come up and we get to this green point here where the red pointer is, okay? This green highlighted point is where we go from the graph coming up to then the graph coming back down, and we can see that. And that is what we call a turning point. It's a turning point because it's a point that we turn direction. We came up here and then we turned and came back down. So that's called a turning point. And similarly for this point here. Now, what I'm going to introduce here is that, well, we know turning points for quadratics. You might have seen them at GCSE. A quadratic looks something like that, okay? A turning point would be that point there, because that's where we go from being kind of coming down here to then passing through the turning point and coming back up. Every graph has the number of turning points that is 1 less than the highest power. So the highest power here is 3, so every cubic will have 2 turning points. But you might ask, where's the turning point here? Well, we don't have this kind of hill-shaped, but we do know at the origin here, we're going up, up, up. In this point here, we then pass through the origin and come up that way. So we can see that the origin there is the turning point, okay? Just a little bit of extra information for you. We'll use that later on in some other videos, but those are the special points of the cubic. Now, you might ask, those 2 examples there are when A is positive, and you saw a little clip a minute ago. This is what it looks like when A is negative. So I'll write it on again. This was an example of y is equal to x cubed. This, and it could be, you know, some kind of multiple of x cubed. This is the negative x cubed graph. So what we have is we have a, let me just find my pointer. We have a graph coming down here like this, and it's negative. So here we were starting coming up. It's negative now, so we start coming down. We again pass through the origin. And the origin for this general graph is a turning point. So we come through here, we pass through the origin or the turning point, and then we start coming back down, okay? So that is when A is less than 0. So a negative here. And again, it could be some multiple of this negative graph. I don't know. I've not got any scaling on my graph. Okay, so we have the version here where we've got some kind of hill-shaped. So let's have a look at what that looks like if we've got a negative A. And it's actually very similar. Just here, we still pass through the origin, but we kind of come down a little bit. We have a turning point, so we're coming down, 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 then we start going up, pass through the origin, we then get to this turning point, and then we start coming back down again. Okay, so again, there's the origin, and that could be some quadratic in this form for A, B, C, and D. Okay, and again, just like we had up here, that's where A is less than 0. Okay, so those are the general kind of looks of a quadratic graph. Now, I want to remind you, what does a root actually mean? We had a look on the graph here, but what can we say about the coordinates of a root? Well, let's say we've got P, and P is some value on the x-axis. If P is, what's under this box? A root. So P is a root. So P could be one of these 3 points here on the graph, or on the negative graph, one of those 3 points. If P is a root of the function f of x, so let's say this was the graph of y is equal to f of x, then the point, it's a function, we've got f of x, then the graph of f of x crosses the x-axis at what coordinate? Well, P is a root, so it must cross at P. On the x-axis, y is equal to 0, so we must cross at the point P0. Okay, so we know what a root is, but I'm just kind of putting that in a little definition there for you. Okay, let's have a look at some examples now. What we want to do is sketch the following cubic graphs, okay? Here we've got a cubic and we can see we've got 3 brackets multiplied together, so it's in factorised form. We're not sure yet how to factorise cubics, we'll get onto that in a minute. So for the minute we're just going to take the factorised form of a cubic. If you were to expand these brackets, you would get something in this general form here, okay? But we'll just take the factorised form. And we want to sketch this graph here, which is x minus 2 times 1 minus x times 1 plus x. And then part B, we want to sketch again, it's in factorised form, x times x plus 1 times x plus 2. Okay, so pause and have a go if you want to. If not, we'll work through it straight away. Okay, hopefully you had a go. If you paused, let's see whether your graph is correct. So what we want to do is we first of all want to find the roots of the graph. And that will help us because we know that if P is a root, it crosses at the point P0. So let's find the roots. Now, how do we find the roots? Well, the roots are on the x-axis. So to find the roots, y is equal to 0. Because on the x-axis, y is 0. So what I'm going to do is I'm going to find the roots by setting y is equal to 0. So when we do that, we're going to get x minus 2, 1 minus x, and 1 plus x equal to 0. Okay, and we can see we've done that because we want to find the roots. And now, just like quadratics, we can set every bracket equal to 0. The reason we can do that is because we've got a multiplication here. And so for this product of the 3 brackets to be equal to 0, either of these 3 brackets can be equal to 0. Because anything multiplied by 0 gives us 0. So x minus 2 can be equal to 0. We can have or the second bracket equal to 0, or the third bracket equal to 0. And then we can just solve for x in those 3 situations. So here, x will be equal to 2. Here, x will be equal to 1. Or here, x will be equal to minus 1. Okay, so those are my 3 roots. And in fact, I'll highlight those in 3 different colours. We'll go with yellow, we'll go with red, and we'll go with green. So I now know 3 values of x, and for those 3 values of x, y is 0. So I can plot those roots on the graph. I can see that I've got a point at, and I'll do it in black first, x is equal to 2. So that's going to be somewhere about there. Now remember, here we have got a sketch. So a sketch, we don't have to have a scale on our axes, just like we didn't have a scale up here. So we only need the important parts of the graph. And that here is our roots, okay? So let's plot the other roots. We've got 1, that's our yellow root, okay? The red root is our x is equal to 1, so that's going to be somewhere about there. That's our red root. And then the green root is at x is equal to minus 1. So that's going to be somewhere about there. Now, as long as it looks correct, we've got sort of the same distance along here than here, and kind of a double the distance from 1 to 2, because that's how it works. We kind of will get the right look of the graph. It doesn't matter if it's not perfect, because it is just a sketch. Okay, so I can draw this on here. Now, what I have to take into consideration is whether A is positive or A is negative, okay? I can see I've got 3 roots, so my graph is going to look something like this, okay? It's going to look something in this shape, but is it going to be starting down here, or is it going to be starting up here? Let's have a look whether A is negative or positive. If we expand these brackets, we're going to get the value of A with the x cubed, okay? So to get the x cubed, well, I can see I'm going to have an x squared from these two brackets here, and I'm going to have a negative x squared, because we'll have that x times that x when we expand the brackets, okay? Now, if I expanded all of these brackets, I might as well do that actually, so you can see, if we expand the last two brackets, I'll have this. I'll have 1 plus x, and then I'll have minus x squared. Okay, checking we've done that correct. 1 times 1 gives me 1, 1 times x gives me x minus x squared. So what I'll get is this cancelling away. So those two terms there will disappear, and what I will have is I'll have this, x minus 2, 1 minus x squared, okay? And then we can expand again, we can expand those brackets to give me x minus x cubed minus 2x plus 2x squared, and then that will give me this. And I'm running out of room a little bit, so we'll just write it down here. Minus x cubed plus 2x squared plus x minus 2. Okay, so all I did was just expand those brackets there. We expanded the first two, simplified, and then expanded those two there. And I can see I have a negative a value, a negative coefficient of x squared, so my a is less than 0. So what that means is we're going to be starting like this. We're going to start up here, we're going to come down, cross through our first root, cross through our next root, come back up, and then back down to this root. Okay, so let's have a look at that. I'm going to start, we'll do it in a blue. I'm going to come down here like this, pass through my first root, and then I'm going to come down, and I'm going to pass through my next root like that. Then I need to come back up and back down so I can pass through that root. And your graph should look something like that, okay? So we don't really need to do all of this expansion every time. We can just think about it in our head, and we can say multiply those two out will give me minus x squared there. Then multiplying by this x, I'll get minus x cubed for one of the terms. So it's going to be a minus graph like that. And it just has to pass through our roots, okay? Now another important thing to add onto a sketch is the y-intercept. And the y-intercept is when x is equal to 0. So let's just do this down here. This is our graph. So we've got y equals, and the y-intercept is when x is equal to 0 because we're on the y-axis. So let's just set x equal to 0 in each of those three brackets. Now when we do that, we're going to have minus 2 times 1 times 1, which is minus 2. And so this point here is minus 2, okay? And then that's it. That's all we have to do for our sketch. Okay, part B, we've got a similar thing, but here we've just got an x out the front, okay? Again, if we wanted, we could really write this like that with a bracket round the x. And then you can see we've got three brackets. The first thing we need to do is find the roots. So let's set the graph equal to 0 because on the roots, y is equal to 0. And then we can say either bracket equals 0. So the first bracket, well, that's just x is equal to 0. The second bracket here is x plus 1. So when that's equal to 0, we'll get x equals minus 1. The third bracket is x plus 2. When that's equal to 0, we'll get x is equal to minus 2. So those are three roots of the graph. So one root, the first one, is at 0. The next one is at minus 1. And the next one, I'm just checking whether this is correct. Yes, it is. The next one is at minus 2. Okay, so it's going to look something like that. Then we need to think, have we got a positive or negative cubic? Well, we need to think, is A greater than 0 or less than 0? And if I expand these three brackets, and you can try it for yourself, expanding these two will give me a positive x squared. Then multiplying everything by x will give me a positive x cubed. And try expanding those three brackets, and you'll see that you're going to get a positive x cubed. So our graph is going to look something like this, but our roots are different. We're still going to have that shape. We just need to pass through our roots. So again, we'll do it in blue. We're going to start here. We're going to come up, pass through this root, but then I need to come back down so I can pass through this root. Then go back down and back up so I can pass through that route, and it needs to look something like that. Now in an exam you might have a better pencil than my iPad pencil, so your graph should look quite smooth, but it should look something like that. And again, we can put on here the y-intercept. Well, the y-intercept here is, well, we passed through the origin, and so that means the y-intercept must be 0. So we've kind of already got it on the graph there. I could put that as a coordinate if we like. Okay, so that is part B and part A answered. So hopefully that makes a little bit of sense. Right, let's have a look at another example. So example 2, again we want to sketch the following graphs, but here we've got a different graph involved here. We do have it factorised, but we've got the same bracket repeated twice. What that is really saying is x minus 1 times x minus 1 times x plus 1, okay? So what do we need to do here? Well, we're going to have 3 roots because it's a cubic, so we're going to have 3 roots, just like a quadratic had 2 roots. Here a cubic will have 3, but you can see if I set each bracket equal to 0, so let's do that, f of x is equal to 0, so each bracket can be equal to 0. We'll get the first one give me x is equal to 1, the second one will also give me x is equal to 1, and the third one will give me x is equal to minus 1. So we need to pass through these 3 roots. We can see here we've got a root twice, and that's called the repeated root. We get that because we've got the same bracket twice. We've got the bracket x minus 1 squared and then this bracket, so we get minus 1 as the root from this bracket and then 1 twice from this bracket because we're squaring it. So in that case, our graph will look something like this. Well, here's the root 1, and then there's the root minus 1. Is it a positive or negative graph? We can see we've got, if we expand x squared from the first 2 brackets, multiplying by this next one, and try it for yourself, expand them, you will get a positive x cubed. And so our graph is going to look something like this. It's going to start, I don't want a straight line, it's going to start, it's going to pass through the root, then we're going to need to continue, but then it's going to think, I need to get down to this 1, so I need to come down like that. And then, well, that's a root, so we need to pass through that, but it's a repeated root. And on a repeated root, I'm just going to draw that again a little bit better. On a repeated root, we get this. It's going to pass through the root, and then because it's repeated, it's going to bounce up like that, okay? And then we can see there's a root and there's another root. So on a repeated root here, it's repeated because we've got x equals 1 twice. We pass through the root that we've got once, we come down, and on our repeated root, we pass through it, and then we flick back up, okay? And that is our graph. And again, we can think about the y-intercept. So the y-intercept, let's think about that, is when x is equal to 0. So we will have y, or f of x in this case, sorry, f of x is equal to 1 minus 1 squared. And that will give me 0 plus 1. So I'm just thinking, have I drawn this correctly? Because it does have... why have I got that? Let me think. We're putting 0 in. Oh, I've put 1 in. There we go. Knew something was not right there. So then we get minus 1 squared and then times 1. So that will give me 1. Okay, because we've got minus 1 squared, which is 1, times 1 is 1. So that point there is 1. Okay, so we can see we've got our 2 roots, which are actually 3, just 1 is repeated. We come up, pass through the root, pass through the repeated root, then flick back up, and then we pass through our y-axis there. Okay, part B is a little bit different. Here, we need to, first of all, find the roots. Now, the roots, we're going to set the graph equal to 0. But how on earth do we solve that equal to 0? Because we don't know how to solve that cubic. Notice here that we don't have a constant on the end. We just have a cubed term, a squared term, and an x term. So each term has a factor of x. So what we can do is factorise out an x from every single term in this cubic. So if we take out a factor of x, we'll have x squared minus 2x minus 3 is equal to 0. And now we can say either bracket is equal to 0. Look, we've got two brackets, so set either bracket equal to 0. I'll come down here. We'll have x is equal to 0, or x squared minus 2x minus 3 is equal to 0. This came from that bracket up there, and then this came from that bracket there. So, what we now need to do is, well, let's see whether this quadratic now factorises. It's a quadratic because the highest power is 2. And that quadratic definitely does factorise. We could say two numbers that times to give me, and I'll just write it here, times to give me minus 3 and adds to give me minus 2. Well, list the factors of minus 3. 1 and minus 3, that definitely works. So, that's going to factorise to that. And then we can say, again, either bracket equals to 0, and that will give me x is minus 1, or x is equal to 3. And so, this here, I'll highlight them in green, that is a root, that is a root, and that is a root. So let's draw those on the graph. X is equal to 0 is there, x is equal to 3 is about there, and x is equal to minus 1 is there. And again, we are doing a sketch, so we don't need any scales on our axes. We just need our roots and then the y-intercept. Okay, so let's have a look at that. What's our graph going to look like? We'll draw it in blue. Is it a positive or negative cubic? In this case, we were given it in its unfactorised form. So we can see straight away here, look at our x cubed term, we can see it's positive. So we're going to have, well, we had a positive here, we're going to have this shaped cubic. We're going to start up here and it's going to have this kind of shape. So, we're going to start here, we're going to come up, pass through the first root, we're then going to continue, then we need to pass through the second root, so to do that we need to come back down, then we need to come down like this, we're going to have, like I said at the start of this video, a turning point, and then we need to pass through this root, so we're going to have something that looks like that. Now here, these points maybe should be a little bit smoother. They should kind of maybe look something like that, but it's a bit hard to get the scaling correct. But as long as you've got this nice smooth shape, then you should be okay. Then we need to think about the y-intercept. Well, we pass through the origin, so the y-intercept just must be 0. So we can see that is what the graph should look like, okay? And again, those are our three roots. Okay, let's have a look at the final example for this video. So press pause if you want to. It's quite tricky. Work through the three parts separately. Part B, you want to use your your answer to part A to answer part B, and then part C, you want to sketch. So press pause and have a go, and when you're ready, press play. Okay, whilst I was having a drink, I hope you got the answer. Let's see whether you were correct. So, part A. We want to express f of x in this form. This form is, well, you can see in the bracket here, this is a quadratic. And then we've got the quadratic multiplied by x. So when we do that, if we expand it, we're going to get a cubic. Now we're given f of x in a bit of a strange form here. We've got two brackets, we've got a quadratic, and then just a sort of linear equation, it's x minus 10. We've got those multiplied together, and then we've got this plus 12x. So what I'm going to do is, the only thing I can do really, is multiply these brackets out and then add the 12x. So let's do that. F of x is, well, if we expand, we can expand along the brackets like that, and multiply along those arrows. We'll get x cubed minus 2x minus 10x squared plus 20x. And then we'll have the plus 12x from there. Okay, so that's what we should get there. And then we can do a little bit of simplification. We can say, right, I've got a x term there, and I've got an x term there, and I'm just checking that is correct. Should we have an x squared? Yes, we should, sorry. We should have an x squared there. You're probably all shouting at the screen. That's better. So we have a x term there and an x term there, okay? So then what we can do is, well, we also have an x squared term there and an x squared term there. We can then collect like terms. So that will say f of x is equal to, well, we've only got 1x cubed. The x squared terms, we've got minus 2 and a minus another 10. That will give me minus 12x squared. And then here we've got 20 and then another 12. That will give me plus 32x. Okay? Then what I need to do is I need to write that in this form here, okay? So we can see I've expanded to give me a cubic, and notice in this example above, we could have factorised out an x from every term. And it gave us something in the form x times a quadratic. Well, can we do that here? We've got x times a quadratic, that's the form that we want. Can we take an x out of every term here? Yes, we can. So that will tell me f of x is equal to, take an x out, we'll have x squared minus 12x plus 32. And that is the form that we wanted it. We can say a is equal to 1, b is equal to minus 12, and C is equal to 32. Okay, just checking and getting my answer that that is correct. Okay, so that is our answer for part A. Then part B says hence. Use your answer to the previous part if one part says hence. So we need to use our answer to part A. We want to factorise f of x completely. Well, factorising it completely, it was a cubic, so to factorise it completely, it's going to be factorised into sort of 3 brackets like that, okay? I'm going to test whether this quadratic will factorise. And because we're being asked to factorise completely, it's kind of a hint that it does. So, let's factorise the quadratic. X squared minus 12x plus 32. I need 2 numbers that times to give me 32 and add to give me minus 12. So listing the factors of 32, that's 1 and 32. That does not work. 2 and 16, that does not work. 3 does not go into 32. 4 does. 4 goes into it 8 times. Now, I'm just going to kind of pause on that one. I can see that if we multiply those 2 numbers together, I will get 32, but adding them will give me positive 12. I want negative 12, so if I put a negative in front of both of those, I'll still get a positive when I multiply, but when I add, I'll get negative 12. So those are the 2 numbers that I'm going to use. So this is going to factorise to x minus 4, x minus 8, okay? And I can then say, and so, f of x will be equal to, well, it was x times the quadratic, but the quadratic has now been factorised into that. So x minus 4, x minus 8. And then that is your final factorised form of the quadratic. So that's our answer to part B. Part C then says hence sketch, showing clearly where f of x intersects axes. So we want the x-axis intercepts, other known as the roots, and we want the y-axis intercept. So let's sketch that here. I'm going to need my graph, and we'll sketch it like that. There is x, and there is, well, here we'll call it f of x, because we've not got y, we've got f of x. So we need to think about the roots. Let's set the graph equal to 0. And if we do that, each bracket can be equal to 0. There's an invisible bracket there, so that will tell me x is equal to 0, x is equal to 4, or x is equal to 8. And those are the three cases when f of x is 0. So these are our roots. Here are the roots. So let's put those on the graph. We've got 1 at 0, so let's put that there. We've got 1 at 4, so let's put that about there. And then we've got 1 at 8, so that's going to be about there. And again, it's just a sketch, so it's not perfect. Okay, we also need the y-intercept, so let's have a look at that. Well, we pass through the origin, and so it's going to be the origin is the y-intercept. Okay, so let's sketch the graph. We'll do it in blue. Is it a positive or negative cubic graph? I can see all of my x's are positive here, so multiplying out, I'm going to get a positive graph. And we could have also seen up here that, well, when we expanded to get our actual cubic, x squared was positive. So let's sketch this on the graph. It's positive, so it's going to start down here. We're going to come through, we're going to continue through that route, then I need to come down to pass through this route. I then need to go down like that, and then I need to pass through, so go back up and pass through 8. So we can see there that that is what our cubic should look like.